Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 152. Please turn to it, page 152, and today is our lesson number 272. 272 on page number 152. The very first problem that we see there on page number 152 is problem number 7. All of these problems that you see there are the exact same problems that appeared in the first edition of the book on the exact same page numbers, and we have already solved all of these problems. If you need to look at the solutions to this problem at a slower pace in more detail, you can go to the day that I tell you. This particular problem number 7, was something that we did on day number 42. Today we're going to redo this problem, but like I said, at a little bit of a faster pace. Here we are given a graph here. Very first thing I'm going to do here is to point out all the points that this graph is going through, because the essence of this problem is actually recognizing where different values occur for a given value of x. What is the given value of y? The given value of y for a given value of x is what is known as the value of the function. For example, point A, let's call it point A, occurs at -3, -2. Let me list all of the points first. Point B, you will see, is -2 and 0. Point C is -1 and +2. Point D is point 0 and +1. Point E is +1 and 0. Point F, you will see that it is point 2, +2 and a +1. And finally we have point G, which is at point +3 and a +1. Of course, these points are not listed on the graph, as I told you before. So now we're going to use these points and draw the graph, reproduce the graph that you see there. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Point A would be -3 and a -2. -3, 1, 2, 3, and -2. Somewhere here is our point A. Point B is -2 and 0. -2 and 0, right here is point B. Point C is -1 and a +2, somewhere here. That's our point C. D is 0 and +1. 0 and +1. That's our point D. Point E is 1 and 0. That's our point E. Point F is 2 and 1. 2 and 1. Is it? 2 and 1. And finally 3 and 1. Point F. Sorry, that was point F. And finally point G is also 3 and 1. That's it, that's our graph. It looks something like this. And the question that they're asking is very straightforward. The question is this: what's the value of the function it appears like this? The key here is to answer, start out with the inside part first, which is this part right here. F. It is read as f of -1. This is how it is read, f of -1, which means what is the value of the function when x equals -1. Now, what does the value of the function mean? Value of the function is another way of saying, it's a very fancy way of saying, value of y. So what they're asking here is, what is the value of the function which is same as saying what is the value of y, what's the value of y when x equals -1? Well, which is very simple. We look at x equals to -1 here, and the value of y is 2, right here. So the answer to this question is very straightforward. It is +2. F of -1 equals +2. So we have done the first step. Okay, watch what happens. So now we know f of -1 is +2. Let me put this back in here. We could put this back in here. And now we repeat the same process. Now the question is, what is f of +2? What is f of +2? Or in other words, f of +2. Now the question is, what's the value of the function when x equals +2? Well, we go back in here, 1 and 2. What's the value of the function when x, what's the value of y when x equals 2? When x equals 2, y equals 1. When x equals 2, y equals 1. Here, when x equals -1, y equals +2. That's it. So you have to do it in steps. That's all. We're done. The answer is 1. Answer is 1. The answer to this question was +1. Let's move on then. That's it. We're done with that question. The key there was to do it in 2 steps. You can't do it in 1 step. Do you understand? You have to do the innermost brackets first. You must always do the innermost bracket first. For example, let me give you a simpler example. If somebody tells you how much is 3 plus 2 times 7 plus -2 times squared times 3, well, you have to do 3 plus 2 first. 3 plus 2 is 5, 5 times 7 is 35, then you do that first, then you do the second bracket right here, and then you do the third bracket. You must start out with the innermost bracket first. That's it, we're done. Let me change this eraser thingy that I have. It's getting quite filthy. That's what it's called, the eraser thingy. Okay, let's move on to the next one then. Number 8. Number 8 is something that we did on day number 43. And the question here is, which statement describes D? Which statement describes D in terms of n? So they're giving us 5 statements, and our job is to pick the one statement that actually gives us a description of D in terms of the other variable. And in order for us to figure out which of this statement describes D correctly, properly, accurately, we have to solve D in terms of n. And here's the equation. D minus 3n over 7n minus D equals +1, we are told. Again, if you need to do this thing slowly, you can always go back and watch day number 43 as I reminded you before. Let's multiply both sides of this equation by 7n minus D. Multiply this side by 7n minus D, multiply that side by 7n minus D, so 7n minus D drops out from here. And we end up with D minus 3n equals 7n minus D, because it's just 1 times that amount. Now all we have to do is bring all the D's on one side and all the n's on the other side. If we were to try to bring this 7n on this side, we'll end up with a negative coefficient for n. I don't like that. Let's bring 3n to that side. And how do we do it? By adding 3n to both sides. And let's bring this D over there by adding D to both sides. That's it. So as you can see, negative 3n and a positive 3n will drop out, which was the whole point. And here we have a positive D and a positive D. D plus D is 2D equals, and again we have a negative D here and a positive D, that drops out, that was the whole bloody point. And we have 7n and a 3n, which is 10n. We're not interested how much 2 times d equals to. We want to know what d equals to. Divide both sides by d. Divide both sides by 2. And there you go. Follow. D equals to 5n. D equals to 5n. In other words, d, see right here, there is an equation here. Okay. What's an equation? A comparable concept in language is a sentence. In languages, we have sentences. In mathematics, we do not have sentences. The comparable concept is what is known as an equation. That's a sentence. We're going to read this sentence now in English language. It says d, this part, equal means is. Equal means is. D is 5, and there is a multiplication sign here. Multiplication means times. And there is your sentence. D is 5 times n. I don't know why I had to do this childish thing. Obviously you can figure it out. D is 5 times n, and that is answer E. The statement that agrees with what we said here is statement E, which is the exact same statement by the way. D is 5 times n. That's it. We're done. There are 2 more problems here, and as I was talking to you right now, I was debating in my mind whether or not I should try to do those 2 problems on the same video. But if I did that, it will become a very long video. Let's not do that. We'll do those 2, the remaining 2 problems that you see there, 9 and 10, in the next video. Alright? I'll see you tomorrow. Bye now.